So this is question 10 from the May 2011 C1 past paper from the WJEC. There's this long paragraph at the front. The only important bit of information that's not in the diagram is this bit here. X is less than 2.5. So we're going to keep that in mind and just skip straight to the questions. So part A. Show that the volume of this tank is given by the equation there. Well, volume is equal to height times length times width, which in this case the height is going to be x centimeters. The length is going to be this 8 meters, but when we fold it up, these two flaps at the sides here and here are going to fold up too, and this x meters will no longer be on the width. So therefore it's going to be 8 minus 2x. And similarly for the width, we're going to get 5 minus the length of these two flaps, which will be 2x also. And when you expand all that out, you get 4x cubed minus 26x squared plus 40x, which is exactly what we wanted to show. And I don't want to spend any more time on part A because part B is the interesting bit. I'll leave this equation up. Find the maximum value of V, showing that the value you have found is a maximum value. So the way we're going to go about doing this, well, we're talking about maximum values. So when we talk about maximum and minimum values of an equation, a good way to consider this is by differentiation. And you're not limited or restricted to applying that to graphs. It'll work for any equation that gives anything, because even though we can draw the tank that's given by this equation, we can also draw the graph of this equation. So what this question is actually asking you is just find the maximum, local maximum of this graph, and then find, and then just show it's a maximum value. So we can consider this like any graph question and just take the derivative of our equation v prime, which equals 12x squared minus 52x, and then plus 40 at the end there. And at the maximum, this is all going to equal 0. So we're going to have this whole equation here, if I just grab that and paste it in, and that's going to be equal to 0. And we can divide through by 3 here, and we end up with 3x squared minus 13x plus 10 equals 0. So that's what happens when we divide through by 4. And then we're going to factorize this. So we're going to have 3x minus 10 and x minus 1 equals 0. So x equals 3.3 recurring, or 1. Now, you may notice that we're told to find the maximum value, singular, of v, and we've got two values here. So what can we do? Well, if we go back to our original paragraph, which I wanted to ignore, we did say that there was this one important bit, x is less than 2.5. So that means that this value, 3.3 recurring, is not a valid answer. So therefore, x equals 1. So our local maximum occurs at 1. Now the last part of this question is prove it's a maximum value, and to do this, you'll remember we just take second derivatives, which is 24x minus 52. We plug in x equals 1, and we end up with negative 28, which is less than 0, so x equals 1 is a maximum. And that's it for this question. That's all you've got to do. It really is just a differentiation and graphing question. It's just a practical application with a box, and it's the only hard part to get the 5 marks is seeing that this differentiation method is valid. So that's all you had to do to get the 5 marks on that question.